Hello, dear students. Today we have chapter 5 that is about nomenclature. Let's see. Let's begin by studying how to name compounds. Binary compounds. They are made of two elements. Uh, you can divide them into one that contains a metal and a non-metal, and those that contain two non-metals. Well, the binary ionic compounds are made of a metal and a non-metal, but they also can be divided into group 1 that are made of a metal from the alkaline metals or the earth alkaline metals, or one from the p block in the representative elements. The type 2 compounds are made of a metal that belongs to the D block or some of the P block, like tin and lead, that has more than one oxidation number. Let's go slowly one by one. For example, when you have here the cations in general has the same name of the element, but the anion change the N by ide. In the case of hydrogen is hydride. In the case of fluorine is fluoride, and so on, as you can see here. Then the cations has the same name of the element, but the anions change the N by ide. Let's see how to name a compound from the group 1 of the ionic compounds. The cation is always named first, and the anion second. A simple cation takes its name from the name of the element, and the simple anion is named by taking the first part of the element name, the root, and adding ide. For example, chloride, and here we have a compound. For example, aluminum has the same name of the element, and chlorine changes the ending by ide, then it's chloride. Then this compound's name is aluminum chloride. Here we have some examples: sodium chloride, potassium iodide, calcium sulfide. Here you have an exercise. Please stop the video and try to answer it. Of course, the answer is selected here. Well, let's go to the binary ionic compounds type 2. In this case, we have a metal from the transition elements and an anion from the non-metals. The charge of the metal ion must be specified. So we use a Roman numeral to indicate the charge of the metal cation, and we write it into parentheses. The transition metal cations usually require a Roman numeral. For example, iron 3 plus is iron, and you use the Roman numeral, the corresponding one. The older name is ferric. I am writing here the older name in just a case that you find this, but this is the actual name or the systematic name. For iron 2, then you put here the Roman numeral into parentheses, and so on for the different elements. Look at this. Tin is a representative element that also has two different charges. So you have to recognize the charge in this case, and the same with lead. Then, what are you going to do in order to name a compound from the type 2 ionic compounds? First, you name the cation using the Roman numeral corresponding to the charge of the cation. Then you say, for example, iron 3, and then the anion is, in this case, is the oxide. Then the name of this compound is iron oxide. Look at this. As you have that the cation has a charge 2 and the anion charge, the cation is 3 plus and the anion 2 negative, then what you do? You multiply the cation by 2, the charge of the anion, and you multiply the anion by 3, that is the charge of the cation. This way, you will have 2 cations. 2 times 3 is 6 plus, and 3 anion. 3 times 2 negative is negative 6. 6 positive and 6 negative is equal to 0. Then the net charge of the compound is 0. Here we have some examples. Copper 1 bromide, iron 2 sulfide, and lead 4 oxide. For example, what is the name of the compound that is represented by this formula? Then you can stop the video and try to see why we choose this answer. Let's continue now to the following slide. Here we have another exercise. Stop the video and try to answer it and to understand. What are the rules for naming type 3 binary compounds? They are formed between two nonmetals. The first element in the formula is named first, and the full name of this element is used. Then it is the same name of the element in the periodic table. The second element is named as though it were an anion. Then you have to change the ending by "ide." Prefixes are used to denote the numbers of atoms present. The prefix mono is never used for naming the first element, only for the second one. Let's see. Mono if you have only one atom in the second element, never in the first one. Di if you have two, tri if you have three, and so on. Remember, it is the case when you have two nonmetals bonded. Here you have some examples. Carbon dioxide. Di because you have two atoms of the oxide anion. Sulfur hexafluoride because you have 6 fluorides. Dinitrogen tetroxide because you have 4 oxide and 2 nitrogen. Here you have another exercise. Stop the video and try to answer it. In general, you have here a chart that shows you how to name compounds, binary compounds. Well, is a binary compound? Yes, then you go. Is a metal present? No, then it's two, three, and you have to use prefixes. Eh, but if you have a metal present, then you have to see if the metal, what type of cation it is. It is a cation that has more than one oxidation number. No, then it is type 1. You use the element name for the cation. But if it has more than one oxidation number, more than one type of charge, then it is type 2. Then you have to put the charge in Roman numeral after the name of the element into parentheses. If we have polyatomic ions, that are those ones that are made of more than one type of element, they have a special names that you must memorize. The oxygen ions are polyatomic anions that contain an atom of a given element and a different number of oxygen atoms. Let's see some examples. Here you can print this table and have it at hand in order to use in these exercises. Here you have oxygen ions that contains oxygen, and you have here another ones that don't contain oxygen, like cyanide or ammonium. Well, for what you have to do in order to name a compound like this. First, you name the cation, in this case is ammonium, and then you name the anion, in this case acetate. Then it is ammonium acetate. In this case, you have different examples of compounds that contain at least one polyatomic ion. In the first case is hydroxide, sodium hydroxide. In the second case is magnesium nitrate. In the third case is ammonium sulfate. And in the last case, you have a transition element. So you have to put the charge into parentheses. What is the charge? Well, you need you need to look at this. The 2 in the phosphate goes as the charge of the iron. So it is iron 2 phosphate. Here you have how to name chemical compounds in general. Is a binary compound? Yes, then use a strategy that we have studied before. Or it is not, then you have a polyatomic ion or ions present. If not, you have to name, this is a compound for which naming procedures have not yet been considered. And if yes, then you have to use the procedure that we have studied for a binary compound, but using the name of the polyatomic ion in the table that we have seen here. Remember to print it. Okay, Here you have an example. Stop the video and you can study why the name is potassium chlorate. Another exercise. Stop the video. Well, acids. Acids are compounds that produce hydronium ions when they are dissolved in water. An example is hydrochloric acid. In this case, the molecule with one or more cations are attached to an anion. For example, hydrochloric acid, hydrocyanic acid, or hydrosulfuric acid. How can you name compounds when they contain a polyatomic ion? Well, the root of the name is sulfate. The 8 changes by ic. Then you say sulfuric acid. Here, in this case, is phosphate. Then you change the ending by ic. Then you say phosphoric acid. In this case, is acetate. You change by ic, acetic acid. But in the case that are binary and one of the is just an anion, a simple anion, you put hydro, then the root of the element, chlor, and the ending ic. Hydroic, hydroic, hydrochloric, hydroic, hydrobromic, and the end, acid. In this case, the name of the anion is nitrate, then you change it by ic, then you say nitric acid. But in this case is nitrite, the ending ite changes by ose, then you say nitrous acid. It will be the same for the following examples. Stop the video. You can print this in order to have an idea when you are going to do exercises of nomenclature. Okay, here we have another exercise. And here you have examples of how to name acids. You have an exercise, and here, let's see, learning to write the formula of a compound. Essential to know that the formula of a compound from X name. Important to learn the name, the composition, and charge of each of the common polyatomic ions and the ammonium cation. And also, you must learn the names of common acids. Okay, that's all for today. If you have any doubt, don't hesitate to call me, please.